This is one of many interesting LED panels available on eBay, and I think this is designed to go into existing bulkhead type fixtures that might take a circular fluorescent tube or a 2D lamp. And what you get is you get the circuit board that goes in and a driver. And I'm guessing that, well, it comes with 3 screws and it's got 3 sort of holes in this, and it comes with the 3 washers. And I would say that although the tracks, I can see they've left quite a void around this sort of screw hole, I would say that the insulated washer is for this side just as an extra layer of protection, because if you're screwing this onto a metal fixture, then effectively the screw would be grounded, and it's to prevent tracking across onto that or shorting out. Although, as I say, it's well clear of the tracks. There's nothing to screw this on with, this driver. We'll take a look inside that afterwards, but actually, we'll test this though. We'll try it out. The arrangement of the LEDs, there are 24. There's 12 on the inside, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 12 on the outside. And they are just seemingly paired. If I bring in the notepad, if this is the positive connection, it appears that the LEDs are paired like this. So you get the one LED pair, and then they're common together, and then they're on to the next LED pair, and it just continues that all the way through the 12. So I'd guess the voltage across this is going to be round about 12 times 3 volts per LED, say about 36 volts across the whole circuit. We'll measure that, we'll check that out with the meter. The power rating is supposed to be 12 watt. It says 12 watt on it, but we can check that. Let's do that. Let's bring in the Hoppy power meter. And this is going to be flickery. It always is flickery, just because of the pulsive modulation speed. Pulsive modulation, that's wrong. The multiplexing speed. And I shall plug the Quicktest into it. The Quicktest, I know that every time I show this, people ask where to get them from. They're available from most UK and European suppliers, and you can now get them in the American colours. I shall try and remember to put a link to that, the supplier. I think it's nodist.com, but I'll check that, and I'll put a link to it in the description. So this connector goes onto the panel. And then this will go in here. And we'll see what sort of power it draws if it works. Oh, bright. That is warm white. Right, tell you what, I'll shuffle this out of the way. I'm not going to assume it's isolated because I don't know what's in here yet. The power is 9 watts, 9.5 watts to be precise. The power factor is a bit shitty at 0.56, but that's to be expected with most of these LED lights. It's very bright. It's very bright indeed. So let's do some electrical tests on this while I've got that lit. Let's bring in a meter and we'll measure the voltage across it for a start. So let's turn this to, optimistically, 200 volt range. I would say round about 36 volts, was it? Maybe a wee bit higher. 39 volts. Okay, that's reasonable enough. What's the current going to be through the LEDs? I can bridge out a pair. If I put this in the 10 amp range, 20 amp range, and I bridge out one of these LEDs, 2 LEDs will actually go out, but that will give me an indication of the current per pair. 190 milliamps per pair, so roughly 100 milliamps per LED, roughly 0.3 watts per LED. What does that work out? There are 24 LEDs. 24 LEDs times 0.3 watts equals about 7.2 watts actual dissipation LEDs. So something must be dissipating from the actual power supply. Okay, let's turn this off and explore the power supply. So I noticed there were other versions of these that had magnets for ease of mounting. The panel itself seemed to come with pre-mounted fixings, but I'm guessing that wouldn't be great thermally. I would think that if you wanted to keep this cool, although it is spreading the heat over a large area, I think you'd want to put some sort of heat sink compound in the back if you were doing it properly, so it coupled onto the metal casing and helped dissipate heat into it. And also you'd want to mount it close up to it. But the other ones, they came with the little standoffs with magnets, so theoretically you just stuck it in. I'm not sure what you'd do with this. You could use double-sided tape to hold it in, that's a bit tacky. But let's open this, let's see what's inside. So I'll get the meters out the way, noting that I've changed this back from the current setting. Now I just want to mention, I want to confess, one of the other meters, I've got a wee note in it that says fuse because I screwed up. I left it in the current setting, so I have to change the fuse in this in the low current range. Annoying. I put it across a battery supply, I think it was, while set to the wrong range. Not to worry, these things happen. And no matter how hard you try, it will happen. All it takes is a moment's distraction, or, you know, when you've originally had it in the current setting and then got distracted and forgot it was there. So let's open this up. What does it say? MT LED driver. Output current 300 milliamps. This looks like a fairly generic 36 to 90 volt, 300 milliamps. It wasn't putting out 300 milliamps. So this might just be a different one. AC 160 to 265 volts. Let's spudge it open. The circuit board is tiny. I was expecting something a lot bigger. Why didn't they just put it in one of the wee tiny boxes then? I'm looking for a wee tiny box up here and I'm not seeing what. Oh, there's one. You'd think they could have stuck it into one of these little boxes. Maybe they just wanted the extra ventilation. Okay. So what's this based on? Let's make sure the capacitor is discharged by sticking my fingers across it. That's a good way, that always works. So what we got? We've got the, let's zoom in this a little bit. And focus on it, just to make sure it's nice and sharp. We've got a bridge rectifier coming in. Have we got any fuse protection? Oh, there's a track fuse on the back, which is alluded to with a little zigzaggy line. We've got the bridge rectifier. We've got that chip. What's the chip? Magnifying glass. The chip is T-Power TP8533E. I think I'll go and check that up. Is it a little... Oh, it's buck. It's a buck regulator, because if you look at the circuit board here, that's not a transformer. All the connections are commoned with that track there, and then all the commoned at the other side. So there's only two connections. So that is an inductor. Right, I'm going to see if I can find the data sheet in this. The joy of the internet. You can just go and find the data sheets. This one is in Chinese, but that's okay. It's one of these products that's not really aimed at the Western market, because we can't really justify using these. We can't manufacture anything remotely near the cost of mass production in China. So here is the circuit of this little chip. It's quite neat. Very minimalist. It is the sort of standard. Now, I can never remember, is that a freewheeling circuit? I think it is. But here's how it works. You've got the mains coming in, through the fuse, bridge rectifier, smoothing capacitor, and then the power supply. Initially, I thought it might actually derive a power supply itself, with this just being an initial charge to actually get the circuit sort of started. But in reality, looking at the plan of the interior of the chip, this is the power supply. It's a resistor, provides current. There's the capacitor for providing the smooth power for the VCC, which is the power for the chip, and the ground connection, that is the power supply for it. ROVP, resistor over voltage protection. I couldn't really find anything definitive in the data sheet for what that is. This is easy. RCS, it's the resistor current sense. Notice that these are all British terminology, or English language terminology. So the current, when this chip operates, current flows from the positive rail through the LEDs, and the inductor, initially the inductor sort of tries to block the current flowing through it as the magnetic field builds up. So it limits the current through. The current flows down through the chip, through the transistor, comes out the current sense and through that resistor. And when the current has reached a sort of high enough level, usually because the inductor is saturated, it can't take any more magnetic field, and it starts just passing the current straight through. As soon as the current exceeds a level whereby the voltage across this resistor rises up to a trigger threshold, probably something like 0.5 volts or something like that, it usually is. When that happens, it turns off. And when it turns off, if that inductor, initially that was the positive side flowing through the LEDs, so that was positive, that was negative. The magnetic field will collapse, so that then goes negative and that goes positive. And the negative is connected to the negative side of the LEDs. The positive goes through this diode and then through the LEDs. So on both the charge and the discharge, well, not, it can't really say that with the inductor. On the build up of the magnetic field and the collapse magnetic field, current goes through the LEDs on both of those cycles. So probably quite efficient then. And it's just super simple. The circuitry is mega simple in that, like they are for most of these devices. It's quite neat. So yes, that's quite stylish. It's a nice warm colour as well. Just zoom back out of that. Just strange that this is so big, but ultimately, maybe it's just because, well, it's to match the appearance of this by having that in the middle, I'm guessing. I'm not really sure. But it's very nice. It's quite a smart little panel.